Welcome to Generative AI Models. After watching this video, you'll be able to identify the core generative AI models that serve as the building blocks of generative AI and list their distinctive features. In the world of generative AI, these four models have made a significant impact: variational autoencoders, generative adversarial networks, transformer-based models, and diffusion models. Each model employs a different type of deep learning architecture and applies probabilistic techniques. Let's gain insight into how they work. Variational autoencoders, or VAEs, are the most popular of all generative AI models for two reasons. A, they work with a diverse range of training data, such as images, text, and audio, and B, they rapidly reduce the dimensionality of your image, text, or audio to create a newer, improved version. First, the encoder, which is a self-sufficient neural network, studies the probability distribution of the input data. In simple terms, this means that it isolates the most useful data variables. This allows the encoder to create a compressed representation of the data sample and store it in the latent space. You can think of this latent space as a mathematical space within the model's architecture, where large dimensional data is represented in a compressed format. Next, the decoder or reverse encoder, which is also a self-sufficient neural network, decompresses the compressed representation in the latent space to generate the desired output. Basically, the algorithms are trained using a maximum likelihood principle, which means they try to minimize the difference between the original input data and the reconstructed output. Although VAEs are trained in a static environment, their latent space is characterized as continuous. Therefore, they can generate new samples by randomly sampling from the probability distribution of data. Because they can produce realistic and varied images with little training data, VAEs are used in image synthesis, data compression, and anomaly detection tasks. For example, the entertainment industry uses VAEs to create game maps and anime avatars. The finance industry uses VAEs to forecast the volatility surfaces of stocks. The healthcare sector uses VAEs to detect diseases using electrocardiogram signals. Generative Adversarial Network, or GAN, is another type of generative AI model that uses imagery and textual input data. In this model, two convolutional neural networks, or CNNs, compete with each other in an adversarial game. One CNN plays the role of a generator and is trained on a vast data set to produce data samples. The other CNN plays the role of a discriminator and tries to distinguish between real and fake samples. Based on the discriminator's responses, the generator seeks to produce more realistic data samples. GANs can generate new realistic-looking images, perform a style transfer or image-to-image translation, and even create deepfakes. The finance industry uses GANs to train models for loan pricing or generating time series. Tools such as SpaceGAN work with geospatial data, and NVIDIA's StyleGAN2 is known for creating video game characters. Unlike variational autoencoders, GANs can be challenging to train as they require a large amount of data and heavy computational power. They can potentially create false material, which is an ethical concern. Transformer-based models were introduced a few years ago, when recurrent neural networks, or RNNs, started facing a problem called vanishing gradients. Due to this problem, RNNs were struggling to process long sequences of text. To get around this challenge, transformers were built with attention mechanisms that could focus on the most valuable parts of the text while filtering out the unnecessary elements. This allowed transformers to model long-term dependencies in text. For instance, when you enter a simple prompt, the two-stack transformer architecture uses an encoder-decoder mechanism to generate coherent and contextually relevant text. As transformer models can query extensive databases, they are able to create large language models and perform natural language processing tasks, such as picture creation, music synthesis, and even video synthesis. This marks a significant breakthrough in our approach to content creation and offers many opportunities for innovation, as has been seen with GPT 3.5 and its subsequent versions, BERT and T5. Diffusion models are a more recent addition to the world of generative AI models. They address the systematic decay of data that occurs due to noise in the latent space. By applying the principles of diffusion, these models try to prevent information loss. Just as in the diffusion process where molecules move from high-density to low-density areas, diffusion models move noise to and from a data sample using a two-step process. Step 1 is forward diffusion, in which algorithms gradually add random noise to training data. Step 2 is reverse diffusion, in which algorithms turn the noise around to recover the data and generate the desired output. OpenAI's DALL-E 2, Stability AI's Stable Diffusion XL, and Google's Imagen are mature diffusion models that generate high-quality graphical content. Similar to variational autoencoders, diffusion models also try to optimize data by first projecting it onto the latent space and then recovering it back to the initial state. However, a diffusion model is trained using a dynamic flow and therefore takes longer to train. Then, why are these models considered the best option for creating generative AI models? Because they train hundreds, maybe even an unlimited number of layers and have shown remarkable results in image synthesis and video generation. Experiments with generative AI models continue unabated as unsupervised algorithms throw up one surprise after another. In this video, you learned about the 4 core generative AI models that serve as the building blocks of generative AI. Variational autoencoders rapidly reduce the dimensionality of samples. Generative adversarial networks use competing networks to produce realistic samples. Transformer-based models use attention mechanisms to model long-term text dependencies. Diffusion models address information decay by removing noise in the latent space. Welcome to Foundation Models. After watching this video, you'll be able to define the term foundation model, explain key characteristics of foundation models, identify the capabilities of foundation models, and explore examples of foundation models. Stanford University Center for Research on Foundation Models defines a foundation model as a new successful paradigm for building AI systems. Train one model on a huge amount of data and adapt it to many applications. We call such a model a foundation model. Let's explore this definition more closely. The first part of this definition says, train one model on a huge amount of data. How does this work? A foundation model is a large general-purpose self-supervised model that is pre-trained on vast amounts of unlabeled data, establishing billions of parameters. Pre-training is a technique during which unsupervised algorithms are repeatedly given the liberty to make connections between diverse pieces of information. This allows foundation models to develop multimodal, multi-domain capabilities such that they can accept input prompts in multiple modalities such as text, image, audio, or video formats, and perform complex and creative tasks such as answering questions, summarizing documents, writing essays, solving equations, extracting information from images, even developing code. This broad skill set makes these models relevant to multiple domains. This is in contrast to smaller generative AI models, which are trained on restricted domain data and requested to perform limited tasks. For instance, OpenAI's DALL-E family of models are considered foundation models because they can perform many image-related tasks. In contrast, AlexNet is not classified as a foundational model, as it only performs image classification tasks. Therefore, we can clarify that while all foundation models have generative AI capabilities, not all generative AI models are foundation models. When foundation models are trained on vast natural language processing databases, they are called large language models, or LLMs. LLMs develop independent reasoning, allowing them to respond to queries uniquely. For example, OpenAI's GPT-N class of models, including GPT-3, which is pre-trained on 175+ billion parameters, and GPT-4, which is pre-trained on an estimated 180+ trillion parameters. Other examples of large language models include Google's Pathway language model, pre-trained on 540 billion parameters. Meta's large language model, Meta AI, pre-trained on 65 billion parameters. Google's BERT, pre-trained on 340 million plus parameters. Meta's Galactica, an LLM for scientists, pre-trained on 48 million papers, lectures, textbooks, and websites. Technology Innovation Institute's Falcon 7B, pre-trained on 1.5 trillion tokens. And Microsoft's Orca, pre-trained on 13 billion parameters and small enough to run off a laptop. It's likely that these parameters may change as generative AI tools evolve in their scope and size. Another aspect of models evolving is their ability to adapt. The definition also suggests that we can adapt a foundation model to many applications. This is possible because of the broad-based training of foundation models, which allows them to learn new things and adapt to new situations. Small businesses can leverage this capability to create customized, more efficient generative AI models at an affordable cost. This is why foundation models are also called base models. They help make AI systems more accessible to businesses and individuals who do not have the resources to train their models from scratch. In this way, foundation models enable enterprises to shrink time to value from months to weeks. Take, for example, the evolution of chatbots. OpenAI's GPT-3 and GPT-4 are foundation models that power the ChatGPT chatbot. Google's Palm powers the Google Bard chatbot. These are today's unreasonably clever chatbots. However, if we think back to how early chatbots functioned, we realize that they were trained on smaller datasets, which confine their generative capabilities. While they could predict responses based on keywords, they could only provide a predetermined response. In contrast, chatbots today are pre-trained multiple times on extensive datasets. They are therefore able to increase their word prediction accuracy and respond in a more helpful and creative manner. Try this, will you? If you type a single sentence prompt in ChatGPT, you'll likely get more than a basic response. Depending on what your prompt requested, the chatbot may write a comparative essay, create an infographic, design a checklist, or script a short story. OpenAI's GPT-3 is also the foundation model for DALL-E, an image generation tool that responds to text prompts. For a single text prompt, DALL-E generates 4 high-resolution images in multiple styles, including photorealistic images and paintings. Another clarification to note here. While all large language models are foundation models, not all foundation models are large language models. Some foundation models use diffusion architecture capabilities to improve the scale and scope of their image generation capabilities. For instance, DALL-E uses transformer architecture, but the latest version of DALL-E uses sound diffusion to generate images from text. Stability AI's Stable Diffusion uses diffusion architecture to generate high-resolution images in realistic, cartoony, and abstract styles based on the user's description. Google's Imagen uses a cascaded diffusion model built on an LLM to generate images from text prompts. As foundation models evolve in their strengths and applications, we have seen some limitations. Firstly, the desired output may be biased if the data on which the foundation model is trained is biased. Secondly, LLMs can hallucinate responses. That means they generate false information because they misinterpret the context of data parameters within a dataset. Therefore, you must verify the accuracy of the output produced by a generative AI chatbot. With a little caution, you can enjoy the many benefits foundation models offer. In this video, you explored the concepts of foundation models. These models are pre-trained on billions of parameters, which allows them to develop independent reasoning and execute a large variety of complex tasks. Given their multimodal, multi-domain capabilities, they can serve as the foundation or base for generative AI applications.
Welcome to the overview video for the project Giving Meaningful Names to Your Photos with IMG Captioning AI. Imagine a world where images are not silent. They whisper stories, reveal hidden details, and open doors to knowledge, all thanks to image captioning AI. Image captioning AI enables transforming the visual information of images into machine-readable language. This technology significantly impacts various aspects, from improving accessibility for visually impaired individuals to enhancing search results and boosting security. By transforming visual data into text, image captioning AI paves the way for deeper content discovery, engaging social media presence, and efficient data management across various fields. In this project, you will be introduced to an automated image captioning AI. Imagine you are a graphic artist surrounded by thousands of unnamed pictures. Finding the right picture feels like searching for a needle in a haystack. So, let's work for a solution to this. In this project, you will work to build an AI tool that does not just look at images, it understands them. And then it creates a text file that acts as an index, giving images meaningful descriptions about what's inside. This makes finding the right picture simple, enhancing efficiency and easing your workload. The project includes step-by-step instructions on how to implement and tailor the image captioning tool for real-world application. For this project, you will perform 3 main activities. Firstly, you will implement an image captioning tool utilizing the Blip model from Hugging Face's Transformer. Blip, or Bootstrapping Language Image Pre-training, can perform various multimodal tasks, including image text retrieval and image captioning. Next, you will employ Gradio to provide a user-friendly interface for your image captioning application. Gradio is an open-source Python package that allows you to build a demo or web application for your machine learning model or a Python function. Finally, you will tailor the automated tool for real-world business scenarios, demonstrating its practical applications by extracting images from URLs and generating captions. To complete this project, you should have a working knowledge of Python and familiarity with utilizing an integrated development environment, IDE. No prior experience with Hugging Face transformers or Gradio is necessary, as you will gain acquaintance with them during the project. By the end of this project, you'll be able to attain the following objectives. Describe the basics of generative AI models, implement an image captioning tool using Python and the BLIP model, and utilize Gradio to create a user-friendly interface for the image captioning application. This project provides an opportunity to acquire skills in harnessing Python functions and exploring the multimodal capabilities of generative AI models. So, get ready to build and implement an AI tool for transforming your photo library by replacing those useless image names with meaningful ones.
Welcome to Hugging Face. After watching this video, you'll be able to explain the purpose of the Hugging Face platform, list the tools and capabilities it offers, and understand how Hugging Face and WatsonX.ai jointly help businesses. Hugging Face is an open-source artificial intelligence platform where scientists, developers, and businesses collaborate to build personalized machine learning tools. The platform was built with the purpose of creating a hub for the open-source AI community to share models, datasets, and applications. This way, AI becomes accessible to all types of users, even those who do not have the budget or bandwidth to build machine learning applications independently. Hugging Face is, therefore, credited with democratizing AI as everyone comes together to benefit from smaller, curated models, challenging the general one-model-to-rule assumption. At first, the Hugging Face community focused on creating transformer-based models to leverage the capabilities of natural language processing, or NLP. However, today, the platform offers various machine learning tools for generating text, images, audio, and video. Currently, the Hugging Face platform hosts over 250,000 open models, 50,000 datasets, and 1 million open demos. This list keeps growing. Scientists and developers use Hugging Face to build, train, and deploy their AI models. They have access to the platform's open-source transformer library, which has over 25,000 pre-trained models for PyTorch, TensorFlow, and Google JAX. PyTorch is a deep learning library, TensorFlow is a machine learning platform, and Google JAX is a machine learning framework. The models in the library perform varied tasks such as text generation, question answering, summarization, automatic speech recognition, and image segmentation, just to name a few. Users can filter these models by name to find an existing model or share their own model with the library. Developers can also host demos of generative AI applications on the Spaces tab, allowing users to interact and validate them. How do businesses benefit from the platform? Hugging Face offers businesses the enterprise hub from where they can access pre-trained models and datasets. This allows businesses to leverage existing infrastructure rather than build models from scratch. Not only does this reduce their carbon footprint, time, and cost to scale, it also allows businesses to train the models on proprietary data and relevant use cases. Additionally, Hugging Face helps businesses A. add or remove features to improve the efficiency of their models, B. evaluate their generative AI models to filter biased data, and C. create multimodal applications with text, image, audio, and video generation capabilities. More than 50,000 large and small companies actively use Hugging Face. For example, Writer, a generative AI solution provider, hosts its Palmyra large language models, or LLMs, on Hugging Face. Intel has officially joined Hugging Face's hardware partner program and is collaborating with Hugging Face to build state-of-the-art machine learning hardware and end-to-end machine learning workflows. Even universities and nonprofits are part of Hugging Face. Among other services, Hugging Face offers an expert acceleration program to guide non-developers on machine learning models. Hugging Chat is the first open-source alternative to chatgpt. To protect its users, Hugging Face complies with Service Organization Control Type 2 regulation. This means ensuring user data security, availability, processing integrity, confidentiality, and privacy. Taking its collaborative efforts one step further, Hugging Face has entered into a unique partnership with WatsonX.ai, IBM's next-generation enterprise studio for AI builders. WatsonX.ai offers select Hugging Face models in its studio to help its community of builders train, test, and deploy all types of machine learning and generative AI applications. This way, the studio leverages the diversity of data, community strength, and open source libraries that Hugging Face provides. On its end, Hugging Face creates open source versions of IBM's LLMs and makes them available on its hub. Both entities believe in open source technology. Both bet on the community to create value in the AI space. As proprietary AI models can quickly become obsolete, Hugging Face may develop an edge over the big five in AI, namely Google, OpenAI, Meta, IBM, and Microsoft. This is because it supports and is supported by the open source AI community that keeps innovating. In this video, you learned all about Hugging Face. This AI platform demonstrates the collaborative power of the open source AI community. It creates space for businesses to build customized proprietary models at a reduced cost, in an accelerated timeframe, incurring a lower carbon footprint. Organizations, universities, and nonprofits leverage the platform's tools and services to benefit from natural language processing. In short, you do not have to be a big business to benefit from generative AI.
Welcome to the overview video for the project Create Your Own ChatGPT-like Website with Open Source LLMs. With the advent of artificial intelligence, or AI, it's now possible to hold an intelligent conversation with a machine. You can extract information on any subject from a computer and save time and effort researching a query, such as, how do I make an HTTP request in JavaScript? How is this possible? This type of assistance is possible through a computer program or chatbot. A chatbot is a computer program that simulates written or spoken human conversation. With the integration of generative AI technology, such as natural language processing or NLP, chatbots can understand questions and respond based on their collected data. The chatbot program takes text as input and delivers a corresponding text as output. A special program called a transformer acts as the brain of the chatbot. The transformer comprises a large language model, or LLM, that helps the chatbot understand the input question and generate the human-like response as the output. The LLM program goes through the data it has collected and creates a response based on machine learning. The transformer manages the technical processing of input and output data, and the LLM focuses on language comprehension and generation. In this project, you will learn to create a simple chatbot with open-source LLMs and integrate your chatbot into a web interface. To build the chatbot, you must select an LLM based on the chatbot's purpose. For example, consider using GPT-2 or GPT-3 models for general-purpose text generation, BERT for sentiment analysis, and T5 for language translation. Other important parameters for choosing an LLM include licensing, model size, training data, and performance and accuracy. In this project, you will work with Facebook's BlenderBot model. It is available with an open-source license through the Hugging Face website. In the project, you will also work with Hugging Face's Python library, Transformers. This library will help you with useful features in building a chatbot, such as interacting with the LLM and optimizing the input into a format the LLM understands. The small building blocks called tokens. You should be familiar with Python and Flask when working on this project. Also, basic knowledge of HTML, CSS, and JavaScript is recommended, but not essential. The project provides step-by-step instructions on working with code and the activities required to build the chatbot using AI tools. By the end of this project, you will accomplish the following objectives: identify the main components of a chatbot, determine the considerations for selecting an LLM for your application, describe how a transformer works, fetch an open-source model and initialize a tokenizer, and program your chatbot in Python. After building a terminal chatbot, you will integrate it into a web interface. To build a chatbot-like website, you need to create a backend server that hosts your chatbot and a front-end web page that communicates with your backend server. In a website, the backend server is like the brain of the application. In a chatbot application, the backend server will receive the prompts from the front-end interface and feed them to the chatbot. The server will then receive the output from the chatbot and display it on the front-end interface. You will be hosting the backend server using Flask. Flask is a Python framework for building web applications. It provides tools and functionalities to handle incoming requests, process data, and generate responses, making powering your website or application easy. By the end of this project, you will have the skills to create your AI-powered chatbot website. You will have a solid foundation in building generative AI-based applications using open-source LLMs. You will use your web development skills with Python and Flask to create an intelligent and interactive chatbot. Get ready for the project. Welcome to the overview video for the project Create a Voice Assistant with OpenAI's GPT-3 and IBM Watson. The domain of voice-based AI is rapidly transforming how we interact with the technology. One particular promising application lies in intelligent voice assistants. Consider a busy professional rushing to design a presentation. With their hands occupied, they can't access their computer for a quick search. However, a voice query to the AI assistant summarize the key trends of use of AI in electric cars allows them to stay informed and productive. Voice AI-based assistants enable you to seamlessly engage in natural conversations, access information, and find answers, all through the power of your voice. In this project, we will create a voice assistant using OpenAI's GPT-3 model and IBM Watson embeddable AI. The GPT-3 model will enable the assistant to understand and respond to user input. The Watson speech-to-text, or STT, empowers the assistant to hear and understand a user's response, and Watson text-to-speech, or TTS, enables the assistant to read the answers back to the user. IBM Watson contains speech libraries for embed, a set of containerized text-to-speech and speech-to-text libraries that help to respond to human speech, process data, and answer questions that help individuals and companies respond to their problems. This project explores chatbots and their applications. You will create a functioning assistant with a high intelligence level that will take voice input and provide a spoken response. In this project, you will begin by developing an environment for building an assistant using Python. Then build your own assistant using GPT-3. And finally, implement IBM Watson to enable speech-to-text functionality. You will also learn to deploy the assistant to a public server. Let's check out a demo of the voice assistant you'll develop in this project. The interface of the assistant displays the title, Voice Assistant. It provides a feature to toggle between light and dark modes. This assistant works with both text and voice. Prompt your questions by typing in the message field or by clicking the recorder icon to speak. For example, what are Shakespeare's tragedies? The assistant provides a detailed response, displaying the text and playing an audio response, showcasing the text-to-speech integration. Continue the conversation by typing or using the recorder option. To conclude, prompts like no and thank you help wrap up interactions with your assistant. To build the voice assistant, you will construct the interface using HTML, CSS, and JavaScript that communicates with the assistant. For building the backend, you will use Python and Flask. Flask is a web framework for building web applications. In the project, Flask is supported by Docker to create containers that manage the dependencies. This is followed by integrating IBM Watson speech-to-text functionality to enable the chatbot to understand voice input from a user. Next, you will integrate GPT-3 for infusing intelligence into the chatbot. Further, you will integrate Watson text-to-speech to give the chatbot a voice for spoken responses. Once all components are combined, you will develop a functioning voice assistant that can take both text and voice input and provide both text and spoken responses. To work on this project, you should be familiar with Python and Flask. Also, it is recommended, but not essential, to have a basic knowledge of HTML, CSS, and JavaScript. The project provides step-by-step instructions on how to work with the code and the different activities required to build the chatbots using AI tools. By the end of this project, you'll be able to obtain the following objectives: explore chatbots and their applications, set up an environment using Python to build chatbots, acquire skills to integrate an LLM to infuse intelligence in a chatbot, implement Watson speech-to-text and text-to-speech functionalities, and create a functioning voice-enabled AI assistant. This project will dive deep into building a powerful assistant. You'll learn about chatbots and web development with Flask and Python. You will also integrate GPT-3 and IBM Watson capabilities to build an assistant with speech recognition. By the end, you will have created a fully functional AI assistant that showcases your newfound expertise working with LLMs using APIs.
Welcome to Introduction to Docker. After watching this video, you will be able to define what Docker is, describe the Docker process and underlying technology, list the benefits of Docker containers, and identify the challenges of Docker containers. Available since 2013, the official Docker definition, paraphrased, states that Docker is an open platform for developing, shipping, and running applications as containers. Docker became popular with developers because of its simple architecture, massive scalability, and portability on multiple platforms, environments, and locations. Docker isolates applications from infrastructure, including the hardware, the operating system, and the container runtime. Docker is written in the Go programming language. Docker uses Linux kernel features to deliver its functionality. Docker also uses namespaces to provide an isolated workspace called the container. And Docker creates a set of namespaces for every container, and each aspect runs in a separate namespace with access limited to that namespace. Docker methodology has inspired additional innovations, including complementary tools such as Docker CLI, Docker Compose, and Prometheus, and various plugins, including storage plugins, orchestration technologies using Docker Swarm or Kubernetes, and development methodologies using microservices and serverless. Docker offers the following benefits. Docker's consistent and isolated environments result in stable application deployments. Deployments occur in seconds. Because Docker images are small and reusable, they significantly speed up the development process, and Docker automation capabilities help eliminate errors, simplifying the maintenance cycle. Docker supports Agile and CI/CD DevOps practices. Docker's easy versioning speeds up testing, rollbacks, and redeployments. Docker helps segment applications for easy refresh, cleanup, and repair, and developers collaborate to resolve issues faster and scale containers when needed. And Docker images are platform independent, so they are highly portable. Docker is not a good fit for applications with these qualities. Require high performance or security, are based on monolithic architecture, use rich GUI features, or perform standard desktop or limited functions. In this video, you learned that Docker is an open platform for developing, shipping, and running applications as containers. Docker speeds up the deployment process across multiple environments. Docker uses namespaces technology to provide an isolated workspace called the container. Docker creates a set of namespaces for every container, and each aspect runs in a separate namespace with access limited to that namespace. Docker supports Agile and CI/CD DevOps practices. And lastly, Docker containers are not a good fit for applications based on monolithic architecture or applications that require high performance or security.
Welcome to the overview video of the project, Generative AI-Powered Meeting Assistant. Imagine you're in a brainstorming meeting. Ideas flying fast and furious, and nuggets of information are being exchanged. You jot down notes, but can you capture everything? Later, recalling key decisions or specific action items becomes frustrating. This is where an innovative generative AI-based app that can transcribe and summarize a meeting's discussions would be helpful. Imagine an app that can transcribe the meeting discussions accurately and then provide a concise summary, highlighting the key points and decisions made. This is the power of combining automatic speech recognition, or ASR, and generative AI-based large language models, or LLMs. You can use ASR technology to convert spoken language into readable text. Then, you can utilize an LLM to comprehend and summarize the text efficiently. An LLM can also refine the speech-to-text output by correcting minor errors, ensuring a coherent and accurate result. This project will guide you through building such an app. You'll utilize an ASR tool called OpenAI Whisper for speech-to-text conversion and leverage Llama 2 LLM's capabilities to summarize and extract key points. Llama 2 is a robust open-source language model by Meta. The project includes step-by-step instructions on building and deploying the app in a serverless environment. First, you will implement OpenAI Whisper to transcribe audio to text using a sample audio file. Next, you build an intuitive and user-friendly interface for the app using Hugging Face Gradio. Further, you will integrate the Llama 2 LLM hosted by IBM Watson X to summarize the transcribed audio effectively. IBM Watson X provides various generative AI models, including Llama 2. You will learn to create a Python script to generate text using the model and some key parameters influencing the model's output. Finally, you will learn to deploy the application online using IBM Code Engine, a serverless platform for running applications in the cloud. For the project, you'll utilize Python to code different activities. so you should have a basic knowledge of the programming language. Let's view the demo of the app you'll develop in this project. This app output will be displayed in Gradio's App Output text box. The app interface displays the title Audio Transcription App. You can upload the recorded audio file using the Click to Upload icon. Click Submit. The summary and key points of the content in the audio file are displayed as the output. By the end of this project, you will accomplish the following objectives. Explain how LLMs can help generate, refine, and summarize text. Implement automatic speech recognition technology for speech-to-text conversion. Design a user-friendly interface for an app. Deploy an application online using a cloud platform for hosting applications. By working on this project, you will lay a solid foundation for using LLMs for text generation and summarization tasks. The project provides an opportunity to demonstrate your Python programming skills to build and deploy an app, leveraging the capabilities of AI speech-to-text conversion and generative AI LLMs. Get ready to apply and upgrade your skills.
Welcome to IBM WatsonX.ai. After watching this video, you'll be able to explain the capabilities and features of IBM WatsonX.ai and identify the common tools available in WatsonX.ai. Generating poem, art, or a song through AI is fun, but when AI is applied to business, you need to think bigger. AI for businesses need to be built based on requirements based on higher standards. When you build AI in the core of your business, it needs to be trusted, secured, scalable, and adaptable. Here is a platform that helps businesses leverage AI IBM WatsonX. IBM WatsonX is an integrated AI and data platform for AI builders. The WatsonX platform comprises 3 products. The first product is WatsonX.ai, a studio for new foundation models, generative AI, and machine learning. The second product is WatsonX.data, which is a data store. And the third product is WatsonX.governance, which is a toolkit for monitoring and governance. In this video, we'll focus on WatsonX.ai. WatsonX.ai is a studio of integrated tools powered by foundation models for working with generative AI and building machine learning models. With WatsonX.ai, you can train, tune, deploy, and manage foundation models easily. This helps you build AI applications in a fraction of the time and with a fraction of the data. With WatsonX.ai, these are some prominent goals you can achieve. Build machine learning models, experiment with foundation models, and manage the AI lifecycle. Based on your goal, you can select the tasks offered by WatsonX.ai. These tasks can be performed using the tools provided on the platform. The tasks and tools in WatsonX.ai align with the AI lifecycle of a model. You prepare your data, build an experiment, and train models and solutions. Then you deploy your models and start building your applications. Subsequently, you manage these models and repetitive processes. WatsonX.ai offers access to IBM selected open source models from Hugging Face, as well as a family of IBM trained foundation models of different sizes and architectures. As an AI value creator, you can also bring your models and data to WatsonX.ai. With tools like PromptLab, AI builders can experiment with foundation models and build prompts that meet their needs. PromptLab enables users to experiment with prompts to support a range of natural language processing or NLP tasks, including question answering, content generation and summarization, text classification, and extraction. As an AI creator, you may also want to customize models based on your data and for your business use cases. WatsonX.ai enables you to do so using the Tuning Studio tool. With this tool, subsequent versions of WatsonX.ai will include tuning methods and examples for prompt tuning and fine-tuning foundation models for better performance and accuracy. Putting a model into a product is a multi-step process. For managing and automating a model lifecycle, WatsonX.ai provides the pipeline tool. The pipeline tool can be used to automate the steps involved in loading data, training models, deploying models, and evaluating models. This can reduce the time to get a model into production and improve the accuracy and reliability of models. Let's learn from this video from IBM how different tools in WatsonX.ai help to create a collaborative environment to streamline workflow for AI models.
Until recently, AI models had to be trained to perform a very specific task. But now, with the power of foundation models, you can build powerful AI applications in a fraction of the time with a fraction of the data. In our prompt laboratory, you can guide models to meet your needs with easy-to-use tools for building and refining performant prompts to achieve your desired result. If you want to further customize, you can tailor models to be even more accurate for your business's use case. In our tuning studio, bring in data sets and tune your model with as few as 100 examples. We provide state-of-the-art tuning methods that you can set up with just a few clicks. Now it's time to put your model to work. Create an enterprise-grade deployment and start building your application. That's it. With WatsonX.ai, your team is empowered by a collaborative environment that streamlines workflows throughout the AI lifecycle. Multiply the power of AI for your enterprise. Practical, efficient, and easy to use. WatsonX.ai.
IBM WatsonX.ai ensures the security of the data and models you work on. Your data and the models you create are accessible only to you. Your data is stored in an encrypted format. The models that you create are also private to your account. IBM does not have access to your data or models, and they will never be used by IBM or any other person or organization without your permission. In this video, you learned about IBM WatsonX, an AI and data platform that helps businesses create AI responsibly and with transparency. One of the products of WatsonX is WatsonX.ai. WatsonX.ai is a studio of integrated tools to train, tune, and deploy generative AI models. Prominent tools offered in WatsonX.ai include Prompt Lab, Tuning Studio, and Pipeline Tool.
Welcome to the overview video for the project Summarize Your Private Data with LLMs and Generative AI. Do you ever feel overwhelmed by the vast amounts of information you encounter daily? Documents, emails, reports? In today's digital age, we're constantly bombarded with data, making it difficult to find the specific details we need. Extracting insights from the overwhelming volume of data is like searching for a needle in a haystack. This is where generative AI and large language models, or LLMs, come in. LLMs are trained on massive data sets. However, when you have sensitive or confidential data you don't want to share with the public model, you can use open source models deployed privately. With the advancements in generative AI models like LLMs, we can create and leverage tools to efficiently parse, summarize, and comprehend vast amounts of data. By understanding and harnessing the capabilities of LLMs, you can transform the landscape of information retrieval. This goes beyond mere efficiency. It opens new frontiers for research, business analysis, and even day-to-day decision-making processes. This project dives into LLMs, providing you with the skills to use LLMs for creating concise summaries and extracting key points from even lengthy documents. In the project, you will create a chatbot that allows you to upload a PDF file. Subsequently, you can post questions to the chatbot regarding the PDF's contents. This chatbot will not only engage with users through text, but also understand and respond to their queries about the specific details in the PDF. Let's check out a demo of the chatbot you'll develop in this project. The chatbot will be accessed as a personal data assistant interface. Here, you'll see an initial message from the chatbot and an option to upload file. Let's upload a PDF document for analysis. For this demo, we'll be uploading a PDF that includes an IBM blog titled 9 Ways Developer Productivity is Boosted by Generative AI. Once uploaded, ask the chatbot any questions about the PDF's content. For example, what are common use cases of generative AI for the development workforce? The chatbot will analyze the content of the PDF and provide answers based on its understanding. To build the chatbot in the project, you will work on a Llama 2 LLM. Llama 2 is a family of open-access LLMs released by Meta. It processes natural language, understands user inputs, and generates text-based responses. In the project, the use of Llama 2 is supported by the Retrieval Augmentation Generation, or RAG technique. RAG will enable Llama 2 to access and leverage information from external sources or the internet. This combination will make the chatbot smarter at giving more accurate and relevant answers. In the project, you will implement the Flask and LangChain frameworks. Flask is a lightweight web application framework in Python that is used to develop the backend of the chatbot, handling HTTP requests and serving responses. The LangChain framework can integrate LLMs into applications, which can be used here to facilitate the interaction between the Flask app and Llama 2 for processing user queries. To work on this project, you should be familiar with Python. Also, it's recommended, but not essential, to have basic knowledge of HTML, CSS, and JavaScript. The project provides step-by-step instructions on how to work with the code and different activities required to build the chatbot. By the end of this project, you'll be able to attain the following objectives: explain how LLMs and generative AI can help to summarize and understand data, implement Llama 2 and RAG for extracting data from large texts, demonstrate web application development using Flask and Python, and apply the LangChain framework to interpret and respond to user inputs effectively. This project will dive deep into building a powerful chatbot application. You'll learn about chatbots, web development with Flask and Python, and harness the power of LangChain to understand and respond to diverse user inputs. By the end, you'll have a fully functional chatbot that showcases your newfound expertise.